Good morning, students. So today I am going to explain about Rodrigues formula. So what is Rodrigues formula? So here it is an equation. Okay, so it is an equation, that is the relation Pn of x is equal to Pn of x is equal to 1 divided by 2 raised to n into n factorial into dn by dx raised to n of x square minus 1 whole raised to n is known as Rodrigues formula. Okay, now we prove this relation. So to prove this relation, we assume that let v is equal to x square minus 1 whole raised to n. V is equal to x square minus 1 whole raised to n. Okay, now differentiating. So after differentiating, what we get? v1. When we differentiate v, we will get v1, so which is same as dv by dx, which is equal to, now differentiate this is of the form x raised to n, so its differentiation is n into x square minus 1 whole raised to n minus 1. Again, differentiation of this x square minus 1 by chain rule into 2x. Okay, now afterwards multiplying both sides with x square minus 1. So after multiplication, we get x square minus 1 into v1 is equal to 2nx into x square minus 1 whole raised to n. So when we multiply with x square minus 1 here, so v1 into x square minus 1 is equal to n into, so x square minus 1 whole raised to n minus 1, and this is x square minus 1 whole raised to 1. So by using the laws of indices, so this gives x square minus 1 whole raised to, this plus 1 and minus 1 get cancelled, x square minus 1 whole raised to only n, and this is 2xn. Okay, so therefore we get this equation 2nx into x square minus 1 whole raised to n. Okay, so or in other words, we can write this one as, now here taking minus common, so it is 1 minus x square into v1 is equal to 2nx into x square minus 1 whole raised to n. Okay, x square minus 1 whole raised to n. Then we get so this is equal to this implies, now as we know that, as we assumed that v is equal to x square minus 1 whole raised to n. So here we replace this by v, so that is, which implies minus of 1 minus x square v1 is equal to 2n. So this is nothing but v, 2n into v into x. Sorry, one more term I forgot to write. This is 2n into x, and here also it is x, or which is equal to 2nx into v, or taking this term to RHS, which implies this minus becomes plus 1 minus x square v1 plus 2nx v is equal to 0. Okay, so now differentiating n plus 1 times, now differentiating differentiating n plus 1 times using a Leibniz rule, So this you have studied in second semester, that is the nth differentiation of standard functions. So there you have studied the Leibniz rule. So okay, so applying n plus 1 times, differentiating n plus 1 times using Leibniz rule. So we obtain this one as, so first we keep 1 minus x square as it is, take the first term, so 1 minus x square as it is. Now differentiating this v1 n plus 1 times, so then it becomes vn plus 2. Okay, so then plus we get this one as minus 2x. Okay, now differentiation of this one, so that is minus 2x into then n plus 1 into vn plus 1. Okay, next is plus n plus 1 into n divided by 2 factorial into differentiation of minus 2x, that is minus 2 into vn. Okay, so this is the first term is over. Next differentiate the second one, so plus 2 n is constant. Now differentiate this one, so first function as it is, differentiation of v n plus 1 times, it is vn plus 1, then plus n plus 1 into differentiation of, here put n is equal to n minus 1, this n, so which is equal to 0. Now after simplifying 1 minus x square into vn plus 2 minus 2x into vn plus 1 plus n into n plus 1 into vn is equal to 0. Or again simplifying, 1 minus x square into this vn plus 2 is the same as d square by dx square of vn, right? d square by dx square of vn means if you differentiate vn 2 times, you will get vn plus 2. Differentiate vn 2 times, you will get vn plus 2. And similarly here 2 into x, this is same as differentiating vn 1 time. So differentiating vn 1 time. Then this one remains the same, n into n plus 1 vn equal to 0. Now which is nothing but, which is the same as Legendre's equation. So which you have studied in the last class. So Legendre's equation is of the form 1 minus x square into d square by dx square minus 2x into dy by dx plus n into n plus 1 into y, which is equal to 0. So which is the same as Legendre's equation. Okay, so and hence Vn is its solution. Okay, so means I am substituting Vn in the Legendre's form. I am substituting y is equal to Vn in the Legendre's equation. We get this is equal to 0. Okay, this is equal to 0. So therefore Vn is its solution. Okay, so now since, so what is V? Actually V is equal to what we have assumed, V is equal to x square minus 1 whole raised to n. Okay, so now therefore differentiating n times, so Vn is equal to dn by dx raised to n, x square minus 1 whole raised to n. Okay, now since it contains a positive powers of x, so therefore it is a multiple of Pn of x. So therefore this can be written as C into constant into Pn of x. constant into, this can be written as constant into Pn of x. Why Pn of x means Pn of x is nothing but what? It is a Legendre's equation of first kind. So there you obtain all the terms are multiple of x square minus 1. So therefore we replace this Vn is equal to C into Pn of x. So that means this means on cross multiplication, so here on cross multiplication, that is C Pn of x is equal to we get this equation, that is C into Pn of x is equal to dn by dx raised to n into x square minus 1 whole raised to n. Okay, or this can be written as dn by dx raised to n into bracket. Now this x square minus 1 is same as x minus 1 into x plus 1 whole raised to n, or this is equal to dn by dx raised to n into bracket. This is the same as x minus 1 whole raised to n into x plus 1 whole raised to n. So now applying product rule, okay, or applying Leibniz rule again, differentiating this n one time. So here first we take as x minus 1 whole raised to n as first term. Now nth differentiation of dn by dx raised to n of x plus 1 whole raised to n. Then we take nc1 into, then differentiation of x minus 1 whole raised to n, it is n into x minus 1 whole raised to n minus 1 into n minus 1th differentiation of x plus 1 whole raised to n. So that is dn minus 1 divided by dx raised to n minus 1 of x plus 1 whole raised to n. Okay, like that we continue, and the last term we obtain x plus 1 whole raised to n into dn by dx raised to n x minus 1 whole raised to n. Okay, so now after simplification, now simplifying, we obtain this is equal to x square minus 1 whole raised to n into n factorial. So why n factorial? Because when we differentiate any function, if the differentiation power of order of differentiation is the same as power of x, then its nth differentiation is n factorial. Suppose that if I want to differentiate d square over dx square x square. Okay, now see here the order of differentiation is 2. And power of x is 2. So both are one and same. So then its second order differentiation is clearly n factorial. So n means n2, so that is 2 factorial. Similarly, if we differentiate d cube y by dx cube for any term x minus 1 whole cube, then clearly the order of differentiation is 3 and this power of x minus 1 is also 3, both are same. Its third order differentiation is clearly 3 factorial. Okay, so write that here nth order differentiation of this x plus 1 whole raised to n is n factorial. Okay, so like that we obtain this as n factorial. Then plus the first term is nc1 into write the remaining term as it is n minus 1 n into x raised to n minus 1 then dn minus 1 divided by dx raised to n minus 1 of x plus 1 whole raised to n. Okay, and so on. The last term we have x plus 1 whole raised to n into, this is again same as n factorial. Okay, so now this is equal. Now this is same as, now what I write? I write the last term. So x plus 1 whole raised to n into n factorial. Then plus these are the terms containing powers of x minus 1. Now see here, this is a power of x minus 1 and this is also a power of x minus 1, and again we obtain all the power of x. So I just write the simple terms containing powers of x minus 1. Okay, so now in this, put x equal to 1 on both sides. X equal to 1 on both sides. So here what we have taken? C into Pn of x we have taken. So here we substitute x equal to 1. Then this is equal to what? N factorial. Then put x equal to 1 plus 1 2 raised to n. So this is 2 raised to n. Okay. 2 raised to n. Now since Pn of remember that always Pn of 1 is equal to 1. So therefore we have obtained, this is C, Pn of 1 is 1, C is equal to n factorial into 2 raised to n. Okay. So substituting all this in 1. So in one way, what is the equation? So this is the equation 1. This is the equation 1. So that is here C okay. So this is the equation 1. Okay. This is equation 1. Now substituting C value. So whatever we obtain of C value in this equation, this is equation 1. Okay. So now what we get? So we get substituting C value, that is C is equal to 2 raised to n into n factorial in equation 1. So that we get Pn of x is equal to Pn of 1 divided by 2 raised to n into n factorial dn by dx raised to n into x square minus 1 whole raised to n. So this is Rodrigues formula. So this is the proof of the Rodrigues formula. So now here you can put in values. Now in this case, putting n is equal to 0, 1, 2, 3 and so on in Rodrigues formula. So that is what in this formula. Put n is equal to 0 first. Okay, so then what we obtain? Put n is equal to 0 first. So n is equal to 0 means this is P naught of x. P naught of x is equal to 1 divided by. So n is equal to 0 means 2 raised to 0 is 1. 0 factorial is again 1. So it is equal to 1. Next is 0 order derivative. So 0 order derivative of x square minus 1 whole. This is n is equal to 0. So again it becomes 1. So therefore P naught of x is equal to what? We get 1. Next put n is equal to 1. So we get P1 of x is equal to, so substitute n is equal to 1. This is equal to 1 divided by 2. 1 divided by 2. Next n is equal to 1. Here n is equal to 1. So that is P by dx into x square minus 1. N is equal to 1. Now this is 1 by 2 as it is. Now what is differentiation of x square minus 1? It is equal to 2x. So which is same as 2 to get cancelled. This 2 to get cancelled. So P1 of x is equal to x. Now similarly n is equal to 2. We obtain P2 of x is equal to. So 1 by 2 square 2 factorial. Then n is equal to 2 means b square by dx square x square minus 1 whole raised to again n is equal to 2. Now differentiating this x square minus 1 whole square 2 times and simplify. So you will get that as 1 by 2 into 3x square minus 1. So this is P2 of x. So similarly continuing like this, we obtain P3 of x is equal to 1 by 2 into bracket 5x cube minus 3x. Next P4 of x is equal to 1 by 8 into bracket 35 x raised to 4 minus 30 x squared plus 3. Next P5 of x is equal to 1 by 8 into bracket 63 x raised to 5 minus 70 x cube plus 15x. Next, n is equal to 6. P6 of x is equal to 1 by 6 into bracket 231 x to the power 6 minus 351 x to the power 4 plus 105 x square minus 5, etc. Okay, like that we obtain the terms. In the next class, we solve problems on this Legendre's polynomial. So these are called as these are known as Legendre's polynomial. Okay, Legendre's polynomial. So this is a Legendre polynomial of order 3. This is a Legendre polynomial of order 4, and this is a Legendre polynomial of order 5, and this is a Legendre polynomial of order 6. Okay, so in the next class we solve the problems on this. Thank you.